What we want to look at now is one called bring to. It's under the operators dynamics category. We're going to go ahead and create our next rule here. We're going to be making a lot of changes on the fly, and the viewport might change quite a bit, so just be ready for that. We can see bring to here has a user interface that says in how many frames do we want to bring these particles to something, and what do we want to bring them to? Well, we want to bring them to this position and this alignment. We don't really see any particle alignment right now. Let's come back here into this first dynamic set where we created these guys. We'll hold Alt and right click that velocity to get rid of them, and we're going to go ahead and just add a shape. Let's add a standard shape. I like using Tetris for this because it actually shows a direction, and then of course we're going to need a size. And when we go ahead and let's see, do we have, yep, edit on the fly and show mesh. So these must just be really small. Let's go ahead and crank up their size value. There they are. We'll change this viewport around. That's what a tetra looks like. One of the problems right now is that they're all kind of pointing in the same direction, and that direction is actually up. This is the head of the particle, and he's aiming this way up. So let's also add something else to affect these particles when they're born. We're going to go ahead and add an alignment operator. An alignment has quite a few options, but the one that we're interested in right now is what it happens by default, is it sets the particle alignment to be random. So these particles are going to end up pointing in different directions. Okay. So what else? We're going to be taking a look at the bring to operator. Over here in the dynamic set, you see bring to is listed above all. That's just kind of bad housekeeping, because really we have the all particles having an output goes into bring to. So bring to depends on all. So bring to should be below all. So we're just going to modify that. Normally, in most cases, TP can sort all that out, but if you get into really complex things or extra dynamic sets listed underneath, it could be a problem. So keep an eye on that. You just want the order of these. You want the data flow to be logical. Okay, so bring to. Let's go ahead and we're going to use a node. Let's create a, yeah, you know, I'm going to import a node that I've made. It's called Axis Helper. And we'll just import him. Axis Helper, of course, has an XYZ indicator, and let's see what he looks like there. He just kind of tells us which way his axes are pointing. Just an easy visual reference. What we want to do is we want to use him to tell all the particles, I want you to go bring to this position. And so we're going to say, now bring to needs a position to use. So we're just going to come over here. Now we could connect it to the scale, but the scale of this guy, this node here, is 1, 1, 1. So we don't really want all the particles to go there. We want them to go to the actual node position. Let's make that connection to position, and node, you can see we have picked him there. And now we go ahead and, so what this means is bring to is going to take these particles wherever they are, anywhere in Max, in the world space, and within 30 frames, it's going to use the old style to bring those particles to this position. Okay, and you can see they get there before frame 30. That's because as it gets, let's see if we do this. If this guy were way out here instead, of course, these particles are going to fly way over there. And it gives them a little buffer time. As they approach their target, they're going to start to slow down. Okay, we'll bring them back. And then this node, of course, also has an alignment. If we want to bring those particles to align themselves like this node, all we have to do is tell bring to's alignment. Let's pull that data from this node. So his alignment is going to be used to drive bring to. Now all those particles are going to be brought to that position and that alignment. So pretty simple there. And the reason that they're pointing off down this direction is you have to remember that with a tetra, the head is actually pointing out this way. And this is the tail. This is the negative z direction. So positive z is that way. Okay, something else that we have is the new style. New style is a different way that gets evaluated for particles to move and approach that position in alignment. It has to do with smooth sticking and soft start. Adjusting those parameters, let's make sure our master dynamic, we're set to edit on the fly off. So if we go ahead and say scrub out here to frame 10, come back into that rule and say, okay, bring to, I want you to have more smooth sticking. You can see they kind of move closer to the target, whereas if we lower that value below 1, they're going to start off, I guess, slower approaching that. Let's go ahead and switch that back to 1 and take a look at soft start. Increasing that's going to kind of make them take more time in the beginning before they get there. You can also see some alignment. They do a little kind of fishtail there. Whereas the old style just kind of does a, it looks almost like either a Bezier interpolation to approach it. Okay, so those are kind of the parameters of bring to. Bring to is very useful if you want to do any object morphing. You can fill one object with a bunch of particles, fill another object with a bunch of particles, and tell each one of those particles to go bring to one of those other particles over there into that other object. Or maybe you just want to have a whole bunch of particles head toward something. You could try to use bring to. And of course bring to also has the on switch here, so maybe if these particles get close enough to this object, you can tell them to turn off and not bring to anymore. Let's go ahead and take a quick look at that just because we brought it up. We use a condition where we want to use a distance condition. We want to detect between the particle's position and this node's position, and we want to say, okay, if the distance is, let's see here, let's use one of these guys. Let's check his radius there. Oh, if the radius is, let's say 50, okay. So between 50 and pretty much infinity, we'll go ahead and, if the particle is outside of 50, but between 50 and what's that, 10,000, 100,000, go ahead and this rule can be true and it will apply. But once those particles are under 50 in distance, this is going to output false because the distance condition is set to say, okay, only if it's between 50 and 100,000 should it be true. So you can see that they enter that circle, and then what happens is the spring 2 is no longer active, but they still have velocity and momentum, so they're being carried forward in their last known good direction, velocity. But then they hit that outer circle again, and then the rule becomes true because now they're within 50 and 100,000, so they're going to want to try to come back, and just going to kind of keep bouncing around to infinity. So they'll really never reach that actual position the way this is set up right now. We could actually change this and maybe say make it 30, and you'll see them kind of, now they'll bounce around closer to it. But anyway, those are just kind of the basics of bring to. I definitely urge you to read through the help file on all of these, on all the operators. There's a great amount of information in there. So we'll go ahead and remove this, and we'll get into our next operator.